The next series of videos contains solutions to implicit differentiation. Learn about the pattern here in differential calculus. Functions can be written in different variations. One type is explicit, which means a function y is defined in terms of x, like y as equal to negative x cubed multiplied by the binomial 3x raised to 4 minus 2. The second type is implicit, where it is the total opposite of the first. Both sides of the equation contain combinations of variables. Applying these two functions in real-life situations, you might notice that implicit functions are more common. With different variables placed together, the differentiation process in implicit functions need not be exclusive. For two variables, differentiation can be taken as dy over dx, or the other way around, the derivative of x with respect to y. The initial problem in the series includes 2x cubed as equal to 2y squared plus 5. The task is to find dy over dx, and since this is just a simple polynomial, start with the distribution of derivatives to each term, providing d over dx of 2x cubed, also d over dx of 2y squared, and d over dx of 5. By applying basic rules, the derivative of a constant is taken as 0, and this will surely shorten the function. Next is to apply the constant multiple rule, and that is by placing the constants before the derivatives. From the left term, take the constant 2 before d over dx of x cubed. Do the same on the right, so take out 2 from d over dx of y squared. We can differentiate as the d's are already simple enough. So start with a constant 2, then the derivative of x cubed, which is 3x squared, with dx over dx. On the other side, the constant is also 2, with the derivative of y squared, which is 2y. Then attach dy over dx. Take note that the variable on the right is y. Thus, its derivative will turn as the derivative of y with respect to x. We can take dx over dx as 1, and also simplify constants, as the 2's can be cancelled from both sides of the equation. So the function is then 3x squared as equal to 2y dy over dx. Because we are looking for dy over dx, divide everything by 2y. So, dy over dx is taken as 3x squared over 2y. How about if for the same function, what we are looking for is dx over dy? The pattern would still remain the same. So the first step is still to distribute d over dy to each term of the function. D over dy of 2x cubed is equal to the first distribution, making d over dy of 2y squared. Then, the second is d over dy of 5. Regardless of which variable the differentiation is with respect to, the rules remain the same. So d over dy of 5 is still 0. The next step is to take out the constants. So, the left side now starts with 2, then d over dy of x cubed. From the right, 2 also comes before d over dy of y squared. Now let's differentiate. Start with the constant 2. Then the derivative of x cubed is 3x squared with dx over dy. The opposite term also starts with 2. Then the derivative of y squared is 2y with dy over dy. Take the last part as 1 and cancel out the constants from both sides. So the simplified equation is 3x squared dx upon dy as equal to 2y. Isolate the d's by dividing everything by 3x squared, which leads to the final differentiation of dx over dy as equal to 2y over 3x squared.